Somebody help me. Life is going nowhere. Somebody help me. Life is going nowhere. Somebody help me. Never mind, I got this.
Hello, this is Sharma. I have a master's degree in math and I'm excited to teach Algebra 1 course. Today's objective is linear equations. Before we take up linear equations, I want to talk about the vocabulary that's associated with linear equations, and then we'll get into linear equations in detail. So the common vocabulary that goes with linear equation is a variable, a term, coefficient, like terms, equation, expression, linear equation, and solution. Would you all go ahead and note down these vocabulary terms? And you've seen these terms before in your previous algebra courses. All of you have had pre-algebra in your school life before you came into algebra, and you've seen these terms before. So let's move on to what a variable is. A variable is a symbol usually represented by X, and it is used for any unknown number. But we can also use any other alphabet for a variable, and it could be A, B, C, or it could be X, Y, Z. It could be any alphabet. And basically, it's an alphabet that's used in place of a number. Now, what's a term? A term is a number, a variable, or a product or quotient of numbers and variables raised to powers. So all these are examples of a term. 9x. This is a product of a number and a variable. 15y squared. That's also a product of a number and a variable that has a power. And here the power is 2. Positive 3, positive 8, m squared n, k, and this is a quotient. We have 2 divided by p. And p is a variable. As I said, x doesn't have to be the variable. It could be any alphabet. So these are examples of some terms. Now what's a coefficient? Suppose I have a term 2x squared. What's the coefficient over here? The number that is before the variable is called the coefficient. A coefficient of a term is the number associated with that term. So we have a number here. Another example is 3xy. What's the coefficient? Can I get some answers?
3.
Yes, 3 is the coefficient. That's our coefficient. Great. Now, terms with exactly the same variables that have the same exponents are like terms. Now, let me give you some examples and some non-examples of like terms. Suppose I have 2x. Let me make it a little darker. Suppose I have 2xy and then I have 3xy. We have two terms here, okay? And let me put a comma. They are like terms. Why are they like terms? Exactly, they have the same variable, but they also have, the variables have the same exponents, isn't it? My x has exponent 1, my y has exponent 1. Here x has exponent 1, y has exponent 1. That is why they are called like terms. So we'll just write next to them like terms. Now let's take up a non-example. Suppose I write something like x squared y, 2x squared y, and then I write 5xy squared. What do you think about this?
They're not like terms.
They're not like terms. They're not like terms because we have the same variable, but we don't have the same exponents. X in the first term has an exponent 2, but x in the second term has an exponent 1. So these are not like terms. So we will right here next to it, not like. In my next slide, I have some more examples for you to see. And let's look at this. What I've underlined is, I have underlined 2. What is 2? We have a term 2m. What is 2 called? Quickly tell me.
Coefficient.
Very good. Excellent answer. It's called coefficient. Let's look at this. 5m cubed. What is 5 over here?
The coefficient.
It's again coefficient. You should be familiar with the vocabulary because, you know, on standardized testing, the language that is used is always important for you to understand all the vocabulary terms. If you don't know the meaning of the vocabulary terms, you will not be able to do well on standardized testing. Is it okay? 5x and 5y, are they like terms?
No.
Why are they not like terms? Who can answer?
2 different variables.
2 different variables, exactly. They had the same coefficients, they had the same exponents, but the variables were different, so they are not like. Let's look at 3x squared and 4x squared. Are they like?
Yes.
They're clearly like. Okay. Now, let's look at the bottom example. 2xy, 4xy squared. Look at them and tell me, are they like terms or they're not like terms?
No.
They're not like terms. That's great answer, but can you give me the reason why?
The exponents are different.
Yes, exponents are different. See how the exponents are different here. Y has got one exponent. On that side, I mean, x had one exponent, and here on the second term, x has one exponent. Now, in the first term, my y has got exponent 1. But what does my second term has?
2.
The exponent for y, it has 2. So these are not like because their exponents were not the same. Let's move on. What's an expression? Who can tell me what is an expression? Because we call this as an expression. We have terms in an expression and the terms are connected with an operation. What is an operation? It could be multiplication, subtraction, division, or it could be addition. Okay? An expression is a statement written using a combination of numbers, operations, and variables. So it could have been +5. This is also an expression. So we have what? A combination of number, variables, and then they are combined by using operations. So this is an expression. Is it okay? Now we are just building our basic parts and building an equation that forms. How various parts get connected to form an equation. That is what we are trying to do. A variable, a coefficient, then a term, and an expression. All these are building blocks of an equation. Okay? Now, we come now to an equation. An equation is a statement that 2 algebraic expressions are equal. Why do I say 2 algebraic expressions? Can you see here there are 2 algebraic equations? There is 2 algebraic expressions. There's one expression on the left side and the second expression on the right side. Can you all see? There are 2 expressions and they are on either side of the equal to sign. The 2 expressions are combined, are connected by this equal to sign, and that is why this is called an equation. So we have 2 algebraic expressions that have been set equal to, and we call such a statement an algebraic equation. And this is not yet a linear equation. This is just an equation. And why this is not a linear equation? Does anyone know? Because I have some students who are, yes?
2a squared.
Yes, exactly, because there is an x squared. That's a very good answer. That is why it is not a linear equation. Okay? Now he said it is x has an exponent 2, and that makes it not a linear equation. So my next slides will give you the definition of a linear equation. Okay, first tell me, what is a linear equation? Okay, who can tell me why do I call this as a linear equation? Because my previous slide said it has 2x squared. Okay, x has an exponent 2.
You said the exponent has to be 1.
Exactly. Fabulous. Fantastic. Exponent has to be 1. The moment your exponent is 1 and your x is by itself, we can't have a combination. We can't have a product of x and y. Okay? It has to be x by itself and x is raised to the power 1. This is an example of a linear equation. So let's read the formal definition of a linear equation. A linear equation is an equation that can be written in the form ax plus b equal to c. There's an equal to sign and we have a variable here, a term here that has x as a variable. X has got just one exponent, okay? And this forms a linear equation. But there is one condition. A cannot be 0. The coefficient of x cannot be 0, because if coefficient of x becomes 0, this terms becomes 0 and we get something like b is equal to c. We no more has an x term. Is it okay? So with the condition a cannot be 0, our linear equation is given by ax plus b equal to c. A number is a solution of an equation if after substituting in the value, the statement is true. We always talk about the solution of an equation, okay? Now, suppose I have a simple equation as x plus 5 is equal to 8. Is it okay? And I say x is equal to 3. And what do we call this as? X is what? X equal to 3 is the solution. Why do we call it the solution? Because if I substitute 3 here in place of x, x plus 5 will become what? 8. And that's equal to my right hand side, which is also 8. So our statement becomes true. And that is why we say this is a true statement. X is equal to 3 is a solution of this equation. Now, with this knowledge, let's go ahead and start identifying the parts of the equation, and then we learn how to solve it. Okay, what is this called? Okay, 7 is called coefficient. Good job. And what is 7x called? Good job. It's called a term. Great answer. Is 8 also a term?
No. Oh.
Yeah, 8 is also a term. A constant, a number can also be a term. It doesn't have to be with a variable, and this is also a term. And there is an equal to sign, so it tells me it's an equation. Okay. Identify the parts of an equation again. What is this? This is what? It's a term, and that has a coefficient? A 30. Good job. Okay. This is again a term, and that's again a term. We'll get into the nitty-gritty of solving an equation towards the later part of the lesson. But at the moment, we're just identifying the parts of an equation. Okay, now this is interesting. Before we get into solving an equation, we have to learn how to combine the like terms. Okay, so what's the first rule of combining the like terms? What do? First, we identify the like terms. Okay, now what are the like terms over here?
W.
Okay.
12W.
Okay. Okay, and all these are like terms, so they all have to be done what? They all have to be ordered or placed together. So we have to do some kind of reordering that they all are put together and the numbers are put together. Okay, so what we'll do, we will write 12W plus 10W. What will I write next to it? Exactly, minus 2w. What do I write next?
Minus 9.
Minus 9 plus 3. Now how do we combine? We add them. We always, we can make mistakes if we try to do everything together. So as a rule, try to do two terms. Try to combine two terms at a time. Okay, so let's do this. What is 12 plus 10? Quickly. 22 minus w minus 2w. Okay, and this we can do later. Let's do two terms at a time. Okay, let's combine 22 minus minus 2w. What do you get? 20. Okay, minus 9 plus 3. I already heard the answer. What's negative 9 plus 3?
6.
Is it just 6? I had heard. Yes, we need to have our addition and subtraction of integers on our fingertips, isn't it? We should be able to tell without the calculator. It will be minus 6. Because we have more negatives than positives, so we will have negative 6 as the answer when we combine negative 9 plus 3. So we have simplified the expression. See, to start with, we had a bigger expression, and at the bottom, we have a simplified expression. And can we combine further?
No.
We cannot combine. Who will tell me why we cannot combine further? Yes.
20 got a variable and 6 doesn't.
Exactly. 20 has a variable and 6 doesn't have a variable. 6 is just a number and they are not like terms, so we cannot combine. Okay. Okay, this is a little complicated. This is like we are going into some advanced problem. Let's try to do this. In this, I will be following please, excuse, my dear.
Sarah.
Exactly, my dear Aunt Sally. Mnemonic. And what is this? What does this remind you of? Order of operations. Okay? We always do what's within the parentheses first. Exactly. So what's within the parentheses? Can we combine something within the parentheses? No, we cannot. So what will we do? We will distribute. What am I going to distribute?
1.
Yes, a negative 1. So don't forget a negative 1. We will distribute the negative 1. So let's do it. Let's start distributing. And let me put these arrows for my visual learners. Because when we distribute equally. We don't just distribute to one term. Okay? So this, good job. Okay, very good answer. It'll be negative 4.
And positive
Plus
y.
Exactly, yes. It'll be positive y squared. Because two negatives, when I distribute my negative 1 to the term inside, we will get a positive y squared. And plus 6y squared within the square bracket. Okay, now within the square bracket, can we combine something?
yes.
Oh, yes. We have some like terms. So let's connect these like terms because they can be combined. Okay, and we will have 2 outside, and let's open our square bracket. What is when there is when there is no number before a variable, we have a 1. Okay, so we will combine them and it becomes 1 minus 3. What is 1 minus 3? Negative 2. Great. Okay, minus 4 plus. Let's combine y squared plus 6. Okay, when there's nothing, there's a 1. 7y squared. Very good. Okay, now inside the square bracket, can anything be can anything be combined? No, we cannot. So it's time for us to distribute. So let me just change the color to for everyone to clearly see what we are doing. We're distributing 2 to all the terms inside the square bracket. So we will get, when I distribute 2 to negative 2y, it will become negative 4y minus 8 plus 14y squared. Okay, do we leave the answer like this, or we can make it look, more better, more sophisticated? What can we do? Who can tell me? Yes.
You put the 14y squared first.
Exactly. We put the 14y squared first because we want the exponents to go in the descending order. Okay, great answer. Everyone agrees? We will put 14y squared first. Okay. After that, what will we put?
Negative
Negative
4y.
Exactly, negative 4y, and then
Negative
exactly minus 8. And now we are done. This is our expression has been simplified. And this is our final answer. We cannot simplify anymore, and we've done all the algebra cleaning. We've combined as much as we could, and we've written in the format that is required. Okay? Okay, now we are moving into solving a linear equation. What we learned was just combining like terms. We learned the vocabulary associated with linear equations, and now we are going to move into solving a linear equation. Okay? Now, we have a solution, but that solution could be consistent or inconsistent. What do you mean by a consistent equation? When you have, consistent solution. We mean by consistent solution is that when I plug in, or when my variable is replaced by that number, the equation is true on both sides. It's a true statement. If I don't get a true statement, then it is called inconsistent. So we must know these vocabulary terms. And then I'll be teaching you how to work with fractions without using calculators. Let's move on to addition property of equality. What is addition property of equality? It is if I add 2 on both sides, our equation remains the same. You know that. We add 2 on both sides, we subtract 2 on both sides, or we multiply by a number on both sides. You may multiply the same amount to both sides of an equation as long as you don't multiply both sides by 0. So there's a condition to it. Never multiply by 0 on both sides of the equation. Okay, you can multiply by any equation, by any number. You can divide by any number. You can add by any number. You can subtract by any number on both sides of the equation. So, let's solve this equation. What do we do first? What's the first step that we do? Yes. We distribute. Great answer. So, let's distribute. We will get 2x plus 6 equal to 4x minus 8. Now the next step is we try to get the variables on one side and the numbers on the other side. That's the whole, concept behind it.
You subtract 4x.
Okay. Let's go by subtracting 4x on both sides, and the two 4x's get cancelled. What is 2x minus 4x?
Negative 2x.
Negative 2x plus 6 is equal to negative 8. What do we have to do now? We have to isolate the x from any number. We have to bring the x. Exactly. Subtract 6 on both sides.
Negative 2x.
Okay. We will get negative 14. Okay. Now how we can isolate the x or bring x by itself? Okay. Because negative 2 was multiplied, so to undo it, I will divide by negative 2.
You're going to get positive 7.
So we will get, my final answer is x is equal to positive 7. Okay. We are not yet done. we need to check it. That's very important component of solving an equation because we cannot be sure of, okay? When we check in, we have something called the left-hand side and the right-hand side of the equation. Okay, we are not sure of whether the two sides will come equal or not. So we put a question mark above the equation. Let's plug in 2 and then x is replaced by 7, 3, close the parentheses, times 10. I get 20 on the left hand side. Let's see on the right side what we get. X is replaced by 7 minus 8. So 4 times 7 minus 8, 28 minus 8, and I'm left with 20. Now, is my left side equal to right side? Exactly. When we get our left side equal to right side, that is when we are sure that our solution is correct. Okay, so solving an equation is just not finding x is equal to 7. An important component of finding the solution is going back and checking our answer and being, doubly sure that what we found was correct. Now we have fractions in this problem. How to work with fractions, and I've written something called remember what you can take, how you can take care of fractions. And this is an important skill that I want to teach you. I don't want you to be dependent on calculators in working with fractions. So how we do it? We try to find a common denominator. What's a common denominator between 4 and 5? There's nothing common between them, isn't it? So it'll be just 20. Just multiply them. Okay? And this is basically it is the least common denominator. And the skill here is multiply your right side everywhere by this 20 and multiply your left side everywhere by 20. So let's multiply. I multiplied the left by 20 and I'm multiplying the right by 20. And once you multiply, it becomes very easy to work with fractions. So anytime you have an equation with fractions, you have to find the common denominator of the least common denominator of 4 and 5. Once you find the least common denominator, here it's 20, I multiply my both sides by the least common denominator. So I multiplied 20 and then I also multiplied my 1 by 20 and I got 20. And here I have 7 times 20 over 5. Okay, now we can cancel. What's 20 divided by 4? Exactly, so this is 5. What is 5 times 3? 15 minus 20. Okay, let's do. How can we divide 20 by 5? 4. Good job. And then we are left with 28. Now we have an equation that doesn't have fractions at all. And we didn't use calculator. Okay, this is a very important and a skill. If you learn, you will never be scared of fractions. If you can find the least common denominator and just multiply both sides by that least common denominator. Add 20 on both sides. I get 15x is equal to 48. Divide by 15, divide by 15. We have x is equal to 48 divided by 15. What can I reduce 48 and 15? What's the greatest common factor that both the terms can be reduced by? 48 and 15. We can try using 3.
3.
Okay, so let's do 3. 3 times 1 is 3 and 6.
The 16.
Okay, because 16 times 3 is 48. Okay, and of course this is 5. So 6 over 5 is the answer. So let me recap what we learned today. We learned about the vocabulary terms that are associated with linear equations. We learned about what a variable is, what a term is, the coefficient of a term. Then we learned how to combine the like terms, and then we moved on to solving linear equations. And yes, we did solve the linear equations, but an important component of solving a linear equation is also going and checking your solution. So once you find your solution, don't forget to plug in your equation and check whether the left side comes equal to right side or not. Thank you.
Somebody help me. Ooh, wait, good God, let me think about it. Well, you can tell by the way I use my walk. I'm a woman's man, no time for talk. Music loud and love and warm, been trying to figure it out since I was born. You know it's alright, it's okay if you believe another way. You can try to understand this new age world effect on man. Whether you're a mother or whether you're a brother, you're still alive.